Entrevista a Frank Wolf, 1. Frank Wolf, me gusta mucho tu nombre, suena muy bien, para una compañía que hace tecnología. Bueno, yo estoy hablando en castellano, en español, porque tenéis que saber que Frank nos estaba comentando que ha vivido en España y puede hablar un poquito de español, ¿verdad, Frank?
Sí, es verdad. Yo he vivido 2 años en Barcelona, he trabajado en el sector de automóvil y después de 20 años estoy aquí en Austria, trabajando como CEO de la compañía OBRIST Powertrain.
Perfecto. Bueno, vamos a hacer la entrevista en inglés justamente porque como vamos a utilizar terminología técnica, pues él prefiere utilizar el inglés para ser más preciso, para ser exacto.
Sí, verdad. Puedo hablar un poco español, pero no es perfecto.
Bien, bien. So, Frank, first of all, OBRIST is an unknown company for Spanish people. Can you please explain us a little bit what do you do here, what are you developing?
Basically, we have to go back a few decades, back into the 80s. At that time, Frank Obrist, the founder of that company here, I was working with Felix Wankel, the inventor of the rotary engine. Maybe some of you remember that NSU was doing this technology, Mazda was doing this technology. So he was working personally with Felix Wankel at the time. Mr. Wankel died in the end of the 80s, just for the record. And then the activities continued until the mid-90s when the Wankel Foundation stopped the operation. And this is when Frank founded this company in 1996. In the beginning, we have been working in the fuel cell sector. We have been working with natural refrigerants. And this has been evolving over the years. And by 2010, we decided to go back to the roots and develop a new powertrain. And that powertrain is called HyperHybrid. Okay, and this is what we're doing for more than 10 years. And we've been building up demonstrator cars. We've been building up, as you can see in the back here, prototype engines, A-sample engines. And in the meantime, we have also a B-sample engine, which will be fitted to the next generation of demonstrator cars.
Okay, thank you very much. And as I was learning yesterday, you are very powerful too in terms of thermal management for cars. Is it correct?
Very, very correct. We have here in Lustenau basically 2 operational companies. One is the OBRIST engineering company, and that company is a technological world market leader in the development of compressors for air conditioning, but also other applications. We also do thermal management, so that means the entire thermal management of a vehicle. But we also do compressors for stationary markets. Our focus there is always emission avoidance, emission reductions. That means we preferably work with natural refrigerants like CO2, and when it's used as a refrigerant, you call it R744, or ammonia, for example, which is also a natural refrigerant, or R290 propane is also. This is where we have a core business where we do development and licensing for many years. Basically, the company stands on 2 feet. One is the engineering foot and one is the licensing foot. So this is the engineering business. And then we have the powertrain company here, which has developed this new type of powertrain. This is in principle a serial hybrid powertrain, what we're looking into. But since we operate this in a special way and a special algorithm, and it has a special engine and precisely developed battery, for this system we call this hyperhybrid, okay? And I'll explain in a minute if you want how this works.
Yeah, because it's very difficult, including me, to understand hyperhybrid if it's not well explained. It's not a hybrid, it's not an electric car, it's not a range extender. Explain us, please, what are the key concepts, the key points of the hyperhybrid concept.
Okay, so first of all, let us start with the definition. What is a serial hybrid, okay? Serial hybrid means there is no mechanical connection between the combustion engine, in our case a power plant, with the wheels, okay? So what you have as key elements on the hardware, you have an electrical motor driving the car all the time, okay? No matter where the current is coming from. So you're an electrical car from this perspective. Then secondly, you have a small high performance battery on the car in the range of 17 kilowatt hour. This is the demonstrator prototype you'll drive today. And this is the second important element on the hardware side. And the third element is the power plant, which we call zero vibration generator. And here we generate only electricity, like in a power plant. Yeah? So this is the hardware. But the meaning of hyperhybrid basically refers to how these 3 components are operated, okay? And this is where we differ a lot from a range extender. So in a range extender, by logic, you would empty a large battery and then you switch on a combustion engine to get home. No, this is not what we're doing. What we're doing here is, we say when we drive in slow mode operation, that means in city limits, we are below 65 kilometers per hour, usually in the towns. This is when this vehicle is driving without the CVG operating. That means we take all the electrical power we need to drive the car from the battery, from the small battery. We also do regeneration there. We do the braking and so on. The energy is sent back into the battery again, okay? Now, when we come to an operational point where we drive faster than 65 kilometers per hour, plus the battery charge has dropped, let's say, to 50%, then we switch on the power plant. And the power plant at this low speed will operate, let's say, at 1500 RPM and generate maybe 15 kilowatt of electricity. We need 7 kilowatt to drive the car. 7 kilowatt will be used to replenish the battery, and 1 kilowatt maybe for the auxiliaries like the air conditioning and so on.
Okay,
yeah?
Really interesting, really interesting. Let's talk about the three key points here. One is the internal combustion engine, one is probably the battery, and then the algorithm that pilots
yes.
all this system. So let's talk about electronics. Let's talk about software.
Yeah.
I suppose it's really tricky, and you need a ton of hours of work to be polite in how it works to maximize the efficiency. How is this work and how it works? What do you have discovered in this trip with the car?
Yeah, the most important thing is that if you switch on the engine needs to be operating at the very high efficiency operating point. So keep in mind, this engine is either not operating and not burning any fuel, or it operates with more than 40% efficiency, which is for a combustion engine very good. Yeah. So this way, this whole vehicle, as you drive it this afternoon, has a fuel consumption in the real world. Okay, so we're driving 150 kilometers and so on per hour on highways and so on, of 2 liter per 100 kilometer. Okay, and 7 kilowatt hours of electrical consumption from the battery. So these are the two energy inputs we have. And basically, when you look into a hybrid or into comparing this to a conventional powertrain today, then I think 2 liter is a very nice offer, because many cars have consumptions of 10, 7, 5 liters, and we have only 2. Okay? Yes, we have the electricity, but the electricity is used from the grid, and preferably here in Austria we use green electricity, so there will be no CO2 emissions. So with this prototype operating on gasoline basis, which you will drive later on, we can cut down the emissions in real world significantly. Of course, if you homologate the car, let's say for Brussels regulations, you have about 1 liter of fuel consumption, okay? But in reality, it will be 2. And that is important for the customer who has to pay at the pump, okay, for high fuel prices right now.
Mm-hmm. Okay. And now the next step, after you have all these components well prepared, well tuned, is to jump to e-fuels to minimize the footprint of emissions. Yep. Please, can you tell a little bit more about your project? Are you working with other companies to develop a real plant? What are the plans in these terms, and what apply to the project of HyperHybrid right now?
Right. So when we operate today, we still have a fuel consumption of 2 liter per 100 kilometers. That is very low emissions, that is clear. So we were thinking, in the future, it will be not possible, and the world will be moving away from gasoline and from diesel and from jet fuel and from coal and gas and so on. It will be a non-fossil world. So let's think about what is the future, okay? Is it pure electric, is it fuel cell, or is it something which is affordable, not so heavy, not using rare resources in the crust of the earth, or minimize that usage? So the idea was to think about what is the right fuel for the future. And the right fuel for the future is something, first of all, which cannot pollute the air. I'm not talking about CO2 in a moment. So first of all, you want to find a molecule that if you burn it in a combustion engine will not generate particulate matter and you can manage NOx emissions. So the whole discussions we had in Europe and elsewhere on the planet too about diesel and air pollutants, you don't want to have that. Again, you want to stay away from that. And this is why you come to the conclusion that you want to use a molecule which has only one C atom, okay? Because if you have only one C atom, you cannot generate particulate matter when you burn it, okay? Important. The NOx you can control via lambda regulation, meaning you mix the air and the fuel appropriately so you don't get NOx, yeah? Now this is one thing when you think about how the molecule should look like. Then the second idea is that this molecule should be able to be produced out of natural stuff. Okay, and by natural stuff I mean salt water. Okay, I don't mean drinking water. I don't want to have land usage where we grow crops and food. So you need to go elsewhere to produce that fuel, and you need carbon. Okay, now the carbon, you have two sources. One is maybe the ocean and the other one is the atmosphere. So the idea was to say, okay, if we choose a molecule, it should have these characteristics. The easiest molecule you can find is methanol. For those who are not familiar with chemical stuff, methanol consists of one C, one O, oxygen, and is surrounded by hydrogen. So it is a very good molecule because it's liquid at 25 degrees and ambient pressure. That is very nice because this way we can use the whole infrastructure as it is, and it has billions of value. We can reuse, we don't have to throw that away. Yeah? And that's a big argument to find a molecule which can be used. Additionally, this molecule which you want to use should be able to be used also on the existing fleet. Okay? Because if the existing fleet continues to drive with gasoline and diesel, then you run into problems, okay? People will hang on to that and you still generate CO2 emissions. So you have to find a molecule which can be used, maybe after an additional conversion step, also for the existing fleet. But also you can use this molecule in a new type of powertrain. And this is what we have done. We have developed the serial hybrid, as I explained earlier, not only for gasoline, but now we made the next step on the engine side and developed a methanol engine, which can operate with methanol. This way, the fuel consumption in liters will go up a bit to 3 liters, but that's not really a point because the energy density of methanol is about half of that of gasoline. So further improvements on the efficiency side will not lead to 4 liters, but to 3. That is basically what we're doing here. But now we do a very important step. When we produce methanol out of seawater and air, using photovoltaic, we interlink this production with a C-sink. That means the CO2 we take from the air, we split that up in carbon and hydrogen and oxygen. And when we do that, the oxygen is given back, like in the forest, back to the atmosphere. And the carbon we use for methanol. Now we can choose. We can use this carbon, yeah, to an extent for the methanol production, but to another extent to take the carbon out of the system. It's very important. Yeah? So in a first step, we use 70% of the sunlight coming in on our photovoltaic plant to produce green methanol, and 30% we use to take carbon out of the atmosphere and store it underground, where mankind took it out for 200 years from coal mines and so on, or from oil pits. So what we have now is 1 liter of methanol, yeah, which is linked to the fact that carbon is stored in the C-sink. So when you burn this liter of methanol in a car, in a plane, in a ship, in a household, yeah, or in a power plant, stationary power plant, then you take carbon out of the atmosphere. So we have been showing this car at the Munich Motor Show, and here we calculated for that car that every kilometer we drive with that car, we take 24 grams out of the atmosphere. They're not adding to the atmosphere, we're taking it out. So in the long run, we have to take as mankind the CO2 which we have emitted over the last 200 years, and in recent decades even increasingly and accelerated. We have to take that back from the atmosphere and get it out of the atmosphere to get rid of global warming, as you all understand, I think. So this is our target, our concern, and this is where this whole team here is working very hard towards, that we can find really a solution for mankind, for all the fossil uses we have today, to replace them with something what we call grandchildren safe. Yeah?
Okay. So if I understand well, you choose methanol because as it has a lot of atoms of hydrogen, is the less power consuming energy to produce any fuel. Is it correct?
Right. The way to methanol on the chemical side is a very simple one. Basically, you need hydrogen and you need CO2. The hydrogen, you take salt water, you desalinate the salt water, then you make electrolysis, your oxygen you give back to the air like the forest, and then you have to capture the CO2 from the atmosphere. There are different processes which have been developed by some companies and partners in this case, and so we can get to the CO2. And these are the two ingredients we need for the synthesis of methanol in the plant.
Okay.
Yeah?
And well, the next question and last question is the future. I suppose you are working, you are trying to show your demonstrator to car brands or to OEMs. Well, I suppose you can't say names, but what's the next point? Are you optimistic your technology will be finally applied in a final solution for consumers?
Yeah, I mean, it is true, I cannot give you any names for confidentiality reasons and contractual reasons. But in the past, you know, we have been developing technology for natural refrigerants. Those technologies you can buy today in an S-Class, for example, okay? There is R74. You can buy natural refrigerants in an ID3 of Volkswagen using the heat pump, for example. So this is the process of this kind of thing. You invent, you write a patent, you show with the demonstrator that it works, and then you license it, and a few years later this is in mass production, okay? And this is what we do here too. So the zero vibration generator has been licensed twice already in the past, and we are working on the licensing of what we call aFuel. So the methanol we want to produce here in some pilot plants will be not called methanol, okay? Because it's not a carbon neutral methanol, but it's a carbon negative methanol. And this is why we call it aFuel, a bit in alignment with the idea to call something e-fuel. This is aFuel, yeah? And this is what is behind. And of course, this will go down the same road as the other technologies, but the customers are of course different. I mean, for a compressor, you have a different licensee than you have for an engine or for a battery or for a fuel. But in principle, this is the same kind of business model.
Okay. And do you think that as we are in a moment where it seems that only electric car is the solution, it will be modulated in the future and we will finally realize, well, not we, but the authority will realize that we need a different alternatives, not single electric cars, to have a realistic automotive solution in the whole world?
I think it is important that we as mankind, as engineers, as companies, investigate different solutions. To prescribe a technology by law is the most expensive thing mankind could do, yeah, and would be very wrong, and by the way is forbidden by European treaties. Yeah? So it makes a lot of sense for the legislator to say we want zero emissions or we want negative emissions and we want it by 2030 or 40 or whatever. And the more severe you make these targets, maybe the earlier something is happening, and that's good. We are not opposing fuel cells or pure electric cars or something like that. We are an electric car, by the way. Don't forget that we have a carbon neutral power plant on board. So we are maybe in many cases more better in terms of CO emissions than a pure battery electric car from a production perspective, but also from an operation perspective. So what we are saying, we need a competition of technology. Why? Because in the end of the day, somebody has to pay for the car and the fuel or the electricity. And that has to be affordable, yeah, on a global basis. If you don't make that affordable, then you cut people away from transport, from energy, and that is, in my opinion, a crime. Yeah? Because if I don't give you energy in a developing country, you cannot develop yourself, okay? So you need to connect people, you need to have energy available. And we have, on the other hand, the obligation as mankind to move away from fossils. So you have to find a solution for that. And let's have competition and see what is the result. I can imagine in some cases a battery electric car in a metro situation, metropolitan situation, is a very good solution. Yeah, in some other cases too. But if you have a country where you have 100% coal power plants, yeah, and there are some, don't need to name them, they are there because for historical reasons, whatever, then it makes no sense to drive an electrical car. Okay, it makes also no sense to go for substances in the crust of Earth which are very, very rare and seldom, and to extract them under very difficult conditions. Okay, that is not good. But you will not avoid those things if you have no competition. There is a competition in order to get the cost for the society and the individual to a minimum level, yeah, but have a real solution for the future.
Okay. So, muchas gracias, Frank. Creo que
no hay de qué. De nada.
Creo que ha quedado muy claro todo. Y nada, un placer escucharte y conocer cuál es el concepto y vuestra solución.
Muchas gracias por el inglés.
No hay ningún problema. Y deseando de poder probar el automóvil, que al final es lo que todos queremos, ¿no? Y por supuesto que te tomo la palabra y me tendréis aquí de nuevo si queréis para probar el Model Y cuando esté disponible.
Sí, verdad, vamos a hacer otra reunión. Entonces puedes conducir el Model Y con el metanol. Y hoy es la máquina con gasolina, pero es el futuro también.
Perfecto, perfecto.
Encantado.
Muchísimas gracias. Gracias.
Muchas gracias.